All right, so we'll look at the last sentence in order to tell what we're looking for. Find the length and the width. So we're looking for two things, and we'll find both of them in the course of solving this. But we're looking for the length and the width. So those are two things we're looking for, and two things that we hope to have by the time we're done with this. And those are the variables that we're going to be using in these sorts of, when we take these statements and change them into mathematical equations. Okay. So the first sentence reads, I want the length, and obviously some of these words don't matter. I want the length of a rectangular sign. I'm just going to highlight the whole thing. To be 3 feet longer than the width. Okay. So we know our variables are going to be L and potentially W. How am I going to represent the word or the idea of a length? L, okay? The length of a rectangular sign. So this is going to be, and you can include the part that says the rectangular sign or not, this is L. Okay. Now here is, it's an action verb, to be. What does that mean in math? Right, just like is or was or will be, it means equals. 3 feet longer than the width. Okay, so a lot of you will want to say 3 plus W, and that's not wrong, but so 3 feet longer than the width. You can say 3 plus W. And that's not wrong, because when you're adding two things together, it doesn't matter what order you're adding them in. But suppose it said 3 feet shorter than the width. You would not want to say 3 minus W. You wouldn't want to say W minus 3. So just for that sort of consistency for, other situations, specifically situations where you want to subtract one thing from another, I'm going to write W plus 3. It doesn't matter here, but it would matter if you were subtracting. You see 3 feet longer than, I would recommend thinking of it as there's going to be a plus 3 at the end of something else. There's something that you're comparing it to, and it's 3 feet longer than it, so it's that thing plus 3. Okay, but we have our first equation. L equals W plus 3. It has a maximum area of 40 square feet. Just go ahead and cross out the word maximum. I don't know why that's there. Has an area of 40 square feet. So now we know that there's an area involved. And so we'll just say A equals 40. I guess has is the sort of operative verb here, that ends up being equals, sort of out of order. The area is 40 square feet. Okay. So, out of all those words, we got two equations. We got L equals W plus 3, and we got the same in that A equals 40. Now, what shape is this sign? Rectangular. Let's see, area, huh? What's the formula for the area of a rectangle?
Length times width.
Yeah, it's, for any rectangle, if this is the length and this is the width, well, it doesn't actually matter which one's the length and which one's the width, as long as, but you multiply them together because it's a rectangle, and area equals length times width. That's the sort of formula that we're going to be starting with. So area equals length times width. Now, according to one of the things, one of the sentences that we sort of translated, what is the area? 40. Okay. Do we have a way to do we have like an alternate way to express the length? Yeah, it's that it's from that equation over there. L equals W plus 3. We'll write it as W plus 3. And what's left? What W? Plus W? Divided by W? Times W. Okay, but then this is just a quadratic equation. It just has to be, sort of figured out. So that W is in the back, but it's the same as if it was written like this. It doesn't matter. So we're going to distribute that W into this W that's in the back. We're going to distribute that into W plus 3. Just to get everything sort of laid out, simplified. So that's going to give me 40 equals. And so what expression is going to be on the right-hand side? If I multiply that W into here. W squared, right? Because W times W is W squared. And then W times 3 is going to be 3W. All right. Now that's looking more and more like a quadratic equation with every step. And since it is a quadratic equation, we will subtract 40. 0 equals W squared plus 3W minus 40. Now, this looks pretty factorable. Two numbers that multiply to negative 40 but add up to add up to 3. What two numbers could that possibly be? Okay, yeah. Minus 5 and plus 8. Those will add up to 3, and they will multiply to negative 40. Okay, so 0 equals W minus 5, and the other factor is W plus 8. Okay. Now, what two values of W are these factors going to give you? Right, so W equals 5, or possibly W equals negative 8. Which one of these is not a realistic width? Negative 8. And why is that? Yeah. We're dealing with a real world sign, not some weird abstract, this is a real sign. So
that's how I realized I got one of the test questions wrong after I submitted it, and I looked at that. I was like, oh. I also left you.
Yeah, I think I answered it. Yeah. Okay, so W equals 5. 1/2 of our answer is here. The other part of our answer, what the length is actually quite easy to get because we have this equation. The length is whatever the width is plus 3. And if the width is 5, then adding 3 would give you the length of 8. So L equals W plus 3, which is just 5 plus 3, which is 8. So the width is 5 and the length is 8. Let's have a less than going on here. So we'll highlight these sentences the same. So first of all, we want to find the dimensions of this garden, which just means, it's a rectangular garden. We're also going to be looking for what L is and what W is. Okay. So first, the area of a square garden is 20 square feet. What is that in math speak, in an equation? Yeah, just A equals 20. Kind of like that A equals 40 from before. Okay, find the dimensions of the garden, right? Means we're looking for L and W. If the length is 3 feet less than twice the width. So it looks like we're going to get another equation here. Now, the length, since we know that L is going to be one of our variables that we're working with, okay, length is L. What about the word is? Equals, okay. And I'm actually going to not do this. I'm actually going to sort of look at that phrase specifically. 3 feet less than. Does that mean that I'm going to take 3 and subtract something from 3? Or does that mean I'm going to take something and subtract 3 from something else? Yes. So what that means is that I'm going to have something and I'm going to subtract 3 from it. What is the thing I'm going to subtract? I don't know why that was so spitty. What is the thing that I'm going to subtract 3 from? Twice the width. Okay. How am I going to represent twice the width? 2W. So L equals 2W minus 3. Not 3 minus 2W. The order does matter here. Which is sort of why I recommend whenever you see the word than to place whatever you're doing sort of at the end, after something else. So the area equals 20. That's one equation that we're working with. And the other equation we just made is L equals 2W minus 3. Cool. So since this is a rectangle, and we're gonna use the same thing here. We're gonna start off with the same A equals LW because, well, we're looking for L, we're looking for W, we're also dealing with the area. The only equation that relates all three, in the context of a rectangle, is area equals LW. All right, so I got my equations all sort of neatened to the side. What is the area? 20, okay. So 20 equals, do I have a different way to express L? Yeah, I'm going to replace that L with 2W minus 3. I'm just going to put a dot here to indicate multiplication, even though it's probably not necessary. And so if I replace L with 2W minus 3, what remains in my equation? Right, times W. And I'm going to do the same as I did last time. I'm going to take this W, and I'm going to distribute it to the inside of this parentheses. I don't care that the W is in the back of this parentheses. It may as well be in the front. So what equation is that going to give me? Okay. 20 equals 2W squared minus 3W. And now I'm going to subtract 20 from both sides. That gives me the equation that is now equal to 0. 2W squared minus 3W minus 20. Okay. Now, that 2 in front of that W squared cannot be factored out because of that pesky minus 3. Minus 3 is not an even number. 2 can't come out of there. So, right. Right, we're going to have to slide and divide. We're going to have to take this 2, slide it to the back, make ourselves, why did I write it 4? Because it becomes 40. But we're going to get the simpler equation, w squared minus 3w minus 40, which may look kind of, well, it's not exactly the same. But if we try to factor this, keeping in mind that we are going to divide, because this is a slide and divide, what two numbers add up to, multiply to negative 40, but add up to negative 3? Right, very similar, but not exactly to the previous numbers, negative 8 and positive 5. Now, what number am I going to divide by? The same number I slided, yeah, 2. Plus 5 over 2 does not simplify. Negative 8 over 2 does simplify to negative 4. So my two factors, this 2w squared minus 3w minus 20, this quadratic factors into two factors, w minus 4, okay, and 2w plus 5. Okay. Now this is going to give me positive 4. Yeah. Let's see. Minus 5, 2w equals negative 5, divide both sides by 2. W equals negative 5 halves. Okay, now out of these, which one is not a realistic width? Negative 5 halves. Shouldn't be negative. So, I should probably pick it up. Okay. The width is 4. And now that we know the width, finding the length should be easy. Where can I plug in this width of 4 to find the length? Yeah, that equation over there that we used in the very beginning. L equals 2w minus 3. So if L equals 2w minus 3, and we know what w is, it's 4, what is L? Yeah, it's going to be 8 minus 3, so that's 5. Okay. Yeah, that sounds about right. 3 feet less than twice the width. Yeah, and they multiply to an area of 20. Yeah, so the width is 4, and as a result, the length is 5. So, I guess to answer your question, Emily, like kind of, but not really, because of this sort of sliding and dividing thing. Like, it doesn't end up being, 5 halves. It does end up being this 5, but so it sort of follows a pattern, but not really. Who remembers the Pythagorean theorem for right triangles? It doesn't actually matter if you don't remember, because it's right there. Use the Pythagorean theorem, a squared plus b squared equals c squared to solve. Now, as for what a, b, and c are, a and b refer to the two legs of a right triangle, and c refers to something called the hypotenuse, which is the longest side of a right triangle. And in case you don't remember, a right triangle is a triangle that has a right angle. So one of these deals. A and B are the shorter sides, called the legs. And C is called the hypotenuse. And it's just a fact of every right triangle ever that if you take the legs, you square both of them, and you add them together, whatever number that comes out to is going to be c squared. It's going to be the length of the hypotenuse squared. Why that's true is not really important here, but it's always an interesting thing to pursue on your own. So we want to, again, we'll skip to the end. Find the length of the legs of this right triangle. Okay. I think it's the best way to approach this. Okay, so just using what you know about yourself and your intuition, do you think you'd be more comfortable if this was like if the variable that we were messing around with was a, or if the variable we were messing around with was like x or something? Or does it not really matter? Right, I mean, we can try both ways. So first, let's introduce as few new variables as possible. And we'll just say that we're looking for a and b in this situation. One leg of a right triangle is 14 feet greater than the other leg. Now, it's not very specific about which leg is which, and honestly, it doesn't really matter, because you're going to find them both anyways. So, one leg of a right triangle that's going to be one of our variables, a or b. And it doesn't matter which one you choose, honestly. We'll just let it be a. The word is not yet. Like we're going to use that Pythagorean theorem eventually, but just not quite yet. 12 feet greater than the other leg. Sorry, 14 feet greater than the other leg. So what is the other leg? Okay, the other leg is represented by b. And what does it mean to be 14 feet greater than? What am I going to do to b? Okay, add 14. A equals b plus 14. Okay, so a equals b plus 14. That is a fact that we know. The hypotenuse is 26 feet. What letter represents the hypotenuse, the long side? C. So C equals 26 is all that that's saying. The hypotenuse is 26. So C equals 26. Now, just like we started off with the area formula, for the area of a rectangle before, this time we're going to start off with the Pythagorean theorem. This a squared plus b squared equals c squared business. Okay. And we're going to use these oh so convenient equations to write this hopefully into something that we can solve. First of all, what's c? 26. So that's 26 that is being squared. Don't forget that it's being squared. So that's the right-hand side of the equation, 26 squared. Is there another way to express a? Right, according to that equation, where one of the legs is 14 longer than the other, we can, instead of a, we can sort of express that as b plus 14. And don't forget that that is also being squared, right? A was squared, so this b plus 14 will be squared. And b squared can just be b squared. So now b is the only variable in our equation, much like in the previous ones, w became the only variable in our equation. So we're going to take b plus 14, and we are going to square it. This is b plus 14 times b plus 14. That's what it means to square something. And if we, you can either FOIL or use, that sort of box deal. B plus 14 across the top and b plus 14 down the side. Okay. B times b is b squared. 14 times b is plus 14b. Again, 14 times b is plus 14b. And 14 times 14 is 196. Man, these really look like sixes. Let me just draw this bigger. Okay, b plus 14. b plus 14. Okay, so when I say this was b squared, nope. Okay, plus 14. How do you write it? Yeah. Okay. Sure. Okay, and plus 196. Okay. If I combine these straight away, which I can because they're like terms, plus 14b and plus 14b, how many b's are there actually? 28. Okay, so this is b squared plus 28b plus 196. Yeah, that, and then there's the rest of the stuff. So plus b squared equals 676. Okay. Wouldn't have thought of that myself. Okay, so first of all, this is a quadratic equation. The first thing I'll want to do is I'll want to combine these like terms. B squared plus b squared becomes 2b squared. Oh my god. Plus 28b plus 196 equals 676. And then I'll just want to subtract 676 from both sides. Okay, that should land me the equation 2b squared plus 28b 480 minus 480. Yeah. Okay. Please don't slide and divide this. How can we take care of that 2 that's in front of the b squared? Right, you can either divide both sides by 2 or factor it out. And even after you factor it out, you can still divide it. I'm just going to factor it out, not that it really matters. But if we factor out a 2, we're going to be left with b squared plus 14b b minus 240 is equal to 0. This actually isn't as difficult as it may seem. It may be the first two factors of 240 that you might think of that turn out to be the correct numbers. What are two numbers that multiply to negative 240 that add up to positive 14? Yeah, so an easy way to break up 240 is 24 times 10. And with one of them being negative because they multiply to negative 240, but 24 and 10, one of them positive, one of them negative, and it turns out that that is exactly what we need to get the two numbers to add up to 14. Positive 24 and negative 10. So this really ends up being, if you didn't divide out the 2, it's technically still here, but this thing ends up being the two factors b plus 24 times b minus 10 equals 0. This will give you b equals negative 24, and this factor will give you b equals 10. Which one of these is not a realistic length of a triangle leg? Negative 24. So, one of the legs is 10. Specifically, that's the shorter leg. The leg that the other leg is more than. So we know that b is 10. And if b is 10, can we figure out a? Yeah, we just take a, and since we know it's b plus 14, that's 10 plus 14, and so that's 24. So a is 24. And it was stated in the problem, but c is 26. But those are the legs. Those are the legs of this triangle, 10 and 24.
You have to write the whole answer a equals b plus 14 dimensions, right? Since we already know that a equals b plus 14.
Can you just say, since you know that b equals 10, do you have to write these steps?
Yeah.
Uh, I mean, you don't have to write this, I guess. No, it's fine. You can just write this and this.
Yeah. A equals 10 plus 14 and then a equals 10.
Oh, okay, yeah. No, that's even better. Yeah, just as long as, you show that you're using the 10 from before to get to the 24. That's totally fine. What are the dimensions of the box? Okay. So, based on this formula that it's telling me to use, and based on the sort of box that it's describing, which I'm going to draw here, you construct an open box with a square base. What that means is that there's no top. There's a bottom and there's a sides. There are sides, but there's no top. It's open on the top, and it has a square base. So what that looks like, just one example of what that could look like, is this. Now it has a square base, so what that means is that if you were to look at it from the top, you would see a square. Okay. Wait, why am I... Yeah, I can see that part of the box. That shouldn't be a dashed line. Okay, good enough. Okay, so you can see it has the sides, it has a bottom, no top. If I look at this formula, it sort of gives you how to calculate the volume of the box, or the surface area of the box. The x squared is going to be because it has a square base. So if you call the length of one of the sides of the box x, knowing that it's a square, you know that the other sides are all going to be the same length. It's going to be x. And so that's going to be the bottom of the box, x times x, or x squared. That's where that comes from. Just if you needed to know why this formula was what it was. I mean, if anything, just be thankful it's like provided to you and that you don't have to figure it out from the description of this box. Now the height of this box is h. And if the height of that box is called h, then each of these four sides is a rectangle. One dimension of which is h, and the other dimension of which is x. So that's x times h. And there are four of these exact same sides. These are the four sides. And when you get your homework, there's going to be one like this. Try to draw this box and label this equation the same way. That'll make it easier for you when you get home. But anyways, that's the box that it's describing. So we're looking for the dimensions of this box. It's its length, its width, which should be the same because it's a square base, and its height. But we're talking about it in terms of x and h. Okay. Now this is the surface area, or in simpler terms, the amount of material used to make the box. So we get a couple of pieces of information here. You construct it from 21 square feet of material. All that's saying is that, man, I'm running out of space. S equals 21. And there's another equation here. The height of the box is 1 foot. Using the variables we're already using, easiest way to say that sort of sentence as a mathematical equation is just that h is 1. And hopefully this knowledge that, it's made from 21 square feet of material and that the height of the box is 1 foot will simplify what we have to do. So we're going to start with this formula that that's given to us, just the same way that we started with the Pythagorean theorem on the previous one and started with the area formula on the ones previous to that. So S is equal to x squared plus 4xh. Do we have something to substitute S with? Is there any other way to write what S is? Yeah, that's 21. And let me write the equations off to the side. S equals 21, and they're actually very simple equations. s equals 21 and h equals 1. Okay, so 21 equals no real way to write no real other way to write x squared plus 4 times x, no other way to write that. Is there another way to write h? Yeah, the height was given to us, it's 1. So if I were to, simplify this, and by simplify this I mean multiplying 4 times 1, what's 4 times 1? 4, so this is just 4x. 21 equals x squared plus 4x. Subtract 21 from both sides, make it a quadratic equation equal to 0 so that you can factor. I'm just going to do that over here. X squared plus 4x, well, 0 equals x squared plus 4x minus 21, which if you factor, what two numbers add up to, sorry, multiply to negative 21, but add up to positive 4? Yeah, positive 7 and minus 3. So this is just x plus 7 and x minus 3. This factor will give you x equals negative 7. And this factor will give you x equals positive 3. Which one of these is probably not the actual side of a box? Negative 7. X equals 3. So this side is 3, because it's just x. What's the length of this side? Also 3. And what's the height? 1, right? We were told what it was. So it's really a 3 by 3 by 1 box.